Morning, AP Physics C students, or good afternoon or good evening, I don't know. This is Matthew Jockmans, and this is your Diff Eq with air resistance or any kind of forces. So here's your scenario. A car starts from rest, looking for the velocity at some time t. Now the only problem is when he did this first, he came up with this equation. Ma equals the force going forward minus kV. Do you see any time in here? No. So we're going to have to integrate this to find the velocity in terms of time. So the whole point of doing this thing is to get velocity and time in there. Is that what you're saying, sir?
Yeah, because acceleration is just a change in velocity over a change in time.
So the first thing you should always do is rewrite that as the reason we do this is because we want velocity and time expressed. But hold on, Kat, my director. I don't have velocity and time here. I have dv and dt. How do you turn a dv and a dt into velocity and time? Why, that's your integration. So the whole, and that's on the letter S. If you don't understand that's an integral symbol, then we got problems. But that's okay. If you don't understand why we're doing it, we want v and t instead of getting dv and dt. Garrett and Kat, you guys are goddamn geniuses. Seriously. Now, in order to do that, to get v and t expressed, I want v and t on different sides. So I'm going to move dt over here, and all the stuff with the v's over here. So step one, let's get rid of that m. The m is disgusting me. I'm going to move dt over here by multiplication. Cool with that? So I'm going to get the m about it. I'm going to divide by m. Divide by fa minus kv. It's kind of like I multiply by dt divided by both sides by m. That is lose you, Kat?
No.
Cool. So the reason we did this is so the dv and v are on one side and the dt is on the other side. So it's kind of like this side of the equation now is how we're going to find the velocity. This side is how we're going to find the time. That's the whole point.
Separation of variables.
Separation of variables. That's a great thing. Sep of var. That means separation of variables. You guys are freaking this is brilliant. Okay. So now, at this point, this side and this side are both going to be integrated. Now I need to choose what we call the opening bounds, and it's from the beginning to end. Looking at this, the car starts from rest. So the initial velocity is 0, and the initial time is 0. At the beginning time, there's no speed. But what's the final time here? Don't know. Let's call it t. I put t equals t because we're going to put t in for any time we have in the integration. And here, we're trying to find the velocity, v equals v. So long story short, when you integrate, we're going to do it kind of twice. Once when v equals 0, once when v equals v, time is 0 times t. Now, the third thing we're going to do to make this simple is we're going to look at this side first. So let's keep all this the same. I'm going to put a little squiggly there, because this is a really easy integration. dt over m integral from 0 to t. Well, there's no t here, so this becomes t over m. We have to do it twice, from when t equals 0 and t equals t. Well, as you can probably understand, when you put 0 in for t, you get 0 at first. When you put in t in, you get this after. So it's just t over m. That's the right side of the equation. Done. This is just simple integration. Gary, you want to say something?
No.
Okay. So now I have the t term. Now I need to get the v term. And that's where it's a lot more difficult. So step 4 is we're going to do the v side. And I'm left with this. dv over fa minus kv. I still have to integrate the left side. The right side, I have t over m. Well, first things first, I want the v in front of it because it makes my form a little bit easier.
Put your bounds in.
I'm sorry, my bounds. V equals 0. I'm going to do that in red because that one it shows the difference. V equals 0, v equals v. So now we're going to switch this up by multiplication to make the form a little bit easier. So we're going to multiply by -1 to make it pretty. And what that gets is dv over kv minus fa, integration again, 0 to v. If I do it to the right side as well, I get negative t over m. We're now going to move to this board. Boop. Boop. Step 5 is this famous U substitution. Looking over here, that's a V, by the way, which is probably important I emphasize that. Look at the bottom. Let's call that U. U is going to equal KV minus FA. So if I put that in, this is what I get. V equals 0 to V equals V of dV, which hasn't changed, over U equals negative T over M. Now, if I wanted to integrate this, I have to change the bounds. But more importantly, these two things are the same variable. That's a no-go. So we have to find what dV is in terms of U. So this is called replacing U, replacing ugly with U. But now we need to get dV in terms of du. Well, if U equals kV minus FA, then du is going to be k times the derivative of v minus, and there's no v in here, this becomes 0. So it's kind of like the differential equation before. So since this goes away, I can now say that dv is du over k. This is now related du to dv. At this point, we're almost done. Step 6 is we're now going to integrate. The bounds haven't changed. I now have du over u, but there's also over k. So I'm going to pull the k kind of in front of it. And again, we're going from 0 to, we're going to put v in eventually, equals negative t over m. Again, this side hasn't changed, it's already been done. With your permission, I'm going to pull the k out in front because it's a constant. Cool with that, Kat?
Cool.
And with your permission, I'm now going to move it on this side because this side's already kind of finished.
Cool.
So this is now move the k out and to the other side. Again, because it's a constant, I don't care about it in terms of integration. D over u, if you look on your formula sheet, you get natural log. So I get natural log of u, but my bounds are to go from v equals 0 to v equals v equals negative tk over m. And this is the simple, it's on your formula sheet of what the integral of like x over dx over x is natural log of x. I'm running out of room, but that's going to be okay. In fact, with your permission, I'm going to come right back at you with a clean board. And we're back. So here's where we're at right now. We're now going to put in u.
Equals.
Yeah, well, we're going to put in for u. So we're going to put in what we had before, natural log, and u was that kv minus fa when v equals 0 and v is v. Now, just like last time, we're going to evaluate this twice. But in this case, since it was an easy division, no addition, when you had 0, everything just went away. This is not that case. When we put v in for v, I get natural log of kv minus fa. It's just putting in v here, which it already kind of is. But then you have to subtract the other bound. And when I put 0 in here, this doesn't become 0. It becomes natural log of 0 minus fa. This is called putting in the bounds. Is that what it's called?
Evaluating.
Evaluating, yeah.
Yeah.
As a reminder, just to give you a sense, when we integrated this side, which was just dt over m, we got t over m evaluated twice. It was t and m when t equals t, minus t of m where t equals 0, which is just 0. So you don't have to worry about that. This is where it matters. Now at this point, this looks really ugly. Let's simplify. This is step 8, which means this is step 9. If you're angry there's 9 steps in a physics problem, welcome to real physics. Okay, I'm going to simplify. This becomes natural log of kv minus fa minus natural log of negative fa equals negative tk over m. Thankfully, we have a cute little thing. When we have natural log of two things, it becomes a simple version. It becomes natural log of first minus second. This is the idea of technical difficulties. Please stand by. This is the old pre-calc thing, I believe, of natural log of A minus natural log of B is natural log of A over B. And finally, number 10. Our original goal was to get V's on one side and T's on the other. We're almost there. Now, how do you get rid of natural log?
E.
E. We're going to do E to both sides. And these two are going to cancel out. Something's left with just inside. KV minus FA over negative FA. But over here, there's no natural log to cancel out, so this becomes E to this power. That's to the power. Now this one, I just want to get V over here, right? I want V's and T's. So we have a little bit of stuff to do. So over here, I just raised by E, both sides. And this one, it's a little bit of algebra. We're going to multiply both sides by the bottom and subtract it. So let's multiply with the bottom first. I'm running out of room real quickly. Multiply by the bottom, and you get KV minus FA equals negative FA e to the minus
KT over M.
KT over M. Now just moving the bottom over. Now we're going to move this over as well. So 12 KV equals FA minus FA e to the minus KT over M. If you're really clever, we can pull a FA out. We'll do it at the end. And then we're going to divide by K. V equals FA minus FA e to the minus KT over M all over K. Which you can also do as FA over K 1 minus e to the minus KT over M. And that's my velocity. So the 30-second summary is you want to get V's and T's on one side versus the other. It takes a lot of calculus to do that. Rewind, watch, hit that subscribe button, do that thing, and come back to class with questions. I'd like to thank Garrett Millard and Ken Rena Gigo. Have a good day.